All right, so we're going to use composite functions to prove inverses. So basically, a composite function is a function that's inside of a function. So you might see a notation that looks like this and wonder, oh my gosh, what is that? You also might see one that looks like this. It means the same thing. The way that you read it is f of g of x. The order does matter. So if I see the next row, I see that this time the G is on the outside. And again, it has a notation that is equivalent to it, G of X, I'm sorry, F. That's an open circle here. So make sure you understand that that's not a zero or a multiplication symbol. That is also, if you're reading it, it's G of F of X. All right, so when you're trying to prove whether or not functions are inverses of each other, when you simplify it, you want your outcome to be X. That tells you that yes, they are in fact inverses. When you have a problem, it's going to give you both of your functions. So I have my f of x in blue and I have my g of x in pink. So together, this is called a composite function, where my g of x is inside of my f of x, where you're used to seeing that x. And what that simply says is every time I am using the f of x function, I want to replace that x with g of x. They told me g of x is this entire expression. So that entire expression will replace that x. So let's get started building. My f of x is the cube root of. Now again, instead of using x there, I'm going to replace it with g of x, which is x minus 8 raised to the third power plus 2. And then I go back to my f of x and I see that I also have a minus 2. So I'm going to put that minus 2 there. And I also have a plus 8. So I'm going to also include that. So this is what I'm working with. And what this is going to allow me to do is to further simplify down. My goal is to try to get to x. Whatever is under your radical, you can go ahead and combine. So I have a positive 2 and a negative 2, which of course is a 0. And if I remember my rules, I taught you guys something about the top dog goes on the inside and then the bottom one is on the outside when we were referring to raising an expression to a power. So this would have looked like x minus 8, top dog is what goes with it. That goes in the house. And then what's on the bottom is your index for your radical. So what you will see is 3 divided by 3 is simply 1, which means that you just have x minus 8. But f of x also had a plus 8 on the outside. So I'm going to have to now combine that information, which leaves me with what I was looking for, x. I can't just do it for one function, though. I have to do it for both composite functions to see if they are, in fact, inverses of each other, because we're trying to compare them. So this time, g is on the outside, so I'm going to build from g. G also starts with the x, which means that I'm going to go back to my f of x, and that's where what I'm going to put first. But it's in parentheses, so I got to keep up with that. Let's see here. So that is cube root of x minus 2 in parentheses. Cube root of x minus 2 is my f of x, and it also has a plus 8 on the outside of that radical. That's just the x portion of my g of x. Now I have to go back and get the rest of my g of x, which is this negative 8 raised to the third power plus 2. Everything that's in the parentheses, I can go ahead and simplify. So I can get rid of the plus 8 and the minus 8. And I know to get rid of a radical, if I have a cube root, I can just cube it. So what I'm left with is that x minus 2, which I can bring down. And I see on the outside, I have a positive 2. Now, what I can just do is simplify. Negative 2 and positive 2 is 0, and I am left with that x. So this tells me in this particular problem or example, yes, they are inverses of each other. So my answer would be yes. Let's go and try another one. For example 2, again, I'm starting off with f, which means I'm going to replace the x for f with whatever g of x is. So I have the fourth root of, instead of writing x, I'm going to go to my g of x and write the entire thing. X to the fourth power plus 9. I go back to my f of x and I see that outside of the parenthesis, outside of the radical, I have a minus 9. What you're going to try to do is combine those, but you can't because one is under the radical and one is not. So therefore, I cannot further simplify that, and I'm definitely not going to end up with an x there. But I still need to go ahead and try my g of x one. So this time I am starting with the g, the entire function for the g, and I'm going to replace that x with the f of x. So that will give me the fourth root of x, and that's raised to the fourth power, because again, I'm going by what's in my g of x, and plus 9. Okay, so, oops, I forgot something. Why you guys didn't tell me? I forgot something. So for my f of x, for this right here, this part right here is the entire f of x. I didn't type in the entire f of x. I have to do that. Now, here we go. And that's raised to the fourth power plus 9. So again, you're going to try to combine these because, oh, there's a negative 9 and there's a positive 9. No, one is inside of the parentheses, that's raised to the fourth power, and the other one is outside of the parentheses. So no, we can't do that. And there's no way this is going to end up being x. This looks confusing, but just think of it as being x minus 9 raised to the fourth power. So you could either use the Pascal's triangle, or you can do x minus 9 times another x minus 9 times another x minus 9 times another x minus 9. It is the same thing, except you would be doing it with, the fourth root. And we don't want to do that. And plus we know that's not going to end up being what we're looking for, which is x. So I can automatically say, no, these are not inverses of each other. Moving on to the last example. All right, so I know you like exponents and logs, so why not use that? So again, we're starting off with our f of x, which has a base of 4, but my x is going to be replaced with everything that is shown in my g of x. So that's going to be log base 4 of x plus 3 minus 27. Go back to my f of x and I see I also have a plus 27. So I have to add that along with that big minus 3. So now I am going to simplify what's in my exponent area. I can get rid of the negative 27 and the positive 27. That's 0. If I remember my rules of the basis, I can get rid of this because that's just 1. What's left over? I bring it down. So I have x plus 3. Well, guess what? I already have a negative 3 over here. That's a big number. So I can go ahead and simplify even further. Plus 3 minus 3. What am I left with? You got it, x. So let's just hope g of f of x gives us the same result. So then we can say that, yes, they are inverses of each other. So now this time we're starting with g because g is what's on the outside. And g of x has log base 4, and you just keep going until you get to an x. Once you get to an x, you replace it with whatever they told you to. They said replace with f of x. So let's go to f of x and use the entire f of x, which is, oops, let's change colors, blue. 4 raised to the x plus 27 power minus a big 3. So that was all of my x, f of x to replace this x. But now I have to finish off my g of x, which is plus 3 parentheses minus 27. So again, what I can do is everything that's inside of the parentheses, go ahead and simplify. Negative 3, positive 3, that's 0. I know my rules say that my bases are the same. I can just bring down that x plus 27. I have a minus 27 on the outside. So I know once I simplify this, I am left with just an x. Well, since both of my composite functions gave me the X as an answer, that means yes, they are actually inverses of each other. Technically, I am finished because I was proving using the composite functions. However, some of you are going to be tempted to use the method I told you in another video, finding an inverse. So finding an inverse is when you were swapping out your X's and your Y's. And you can do that if your instructions don't explicitly tell you to use the composite function, but you have to follow those instructions. So if I swapped out my X's and Y's, I'm going to have X is equal to 4 raised to the Y plus 27 minus 3. And now I know I want to go ahead and move that negative 3 over. So I'm going to have X plus 3 is equal to 4 raised to the Y plus 27. Guess what? We're going to rewrite this thing, and we're going to rewrite it as a log. So that will be log base 4 of X plus 3. I already know I'm going to have to subtract 27, so I'm just going to go ahead and do that. Minus 27 is equal to Y, which we would rewrite it as the inverse of f of X. And guess what? What does that look like? Amazing, isn't it? Yes, that's one way, but you would have to do it for both. But again, only if your instructions do not specifically say, come on, eraser, if they do not specifically say prove using the composition of functions, because if it says that, then you have to do it the way that I just showed you, where you're looking for the X. So the way I just showed you just now is what I showed you in another video, finding the inverse. So let's do g of X. We're going to swap it out. We're going to say that's X is equal to log base 4, and this is Y plus 3 minus 27. Well, let's go ahead and add 27 on both sides, which will get rid of this. And that's going to leave us with log base 4 of Y plus 3. So now I want to put it in exponential form, get rid of that log. So that will be 4 raised to the X plus 27 is equal to, actually, I'm just going to go ahead and subtract my 3s. Minus 3 is equal to the inverse of f of X, or g of X in this case. So guess what? Ta-da! That's another way of, again, doing the problem if your instructions do not explicitly state, I don't know why my eraser is not working. If it does not explicitly state that you have to prove using the composite function method. All right, my computer is super hot and is doing something crazy right now. So for now, if you don't mind, please subscribe and hit that thumbs up.